Okay, good afternoon. I hope you're enjoying the snow, the break that you get. Sorry we didn't have class today, but we're going to make up for it by looking at some videos. How about that? You can use the spreadsheet that's on Canvas for today. It's under the on 321 Excel spreadsheet that I posted. I'll be using that today. I'll use it in Google Sheets. I also have some slides to go through for you. I also have an announcement to make. This is for the near next few weeks future. You need to be thinking about final exam conflicts. It's possible that some of you may have conflicts with the final exam time, and you need to be thinking about that early. Every semester I have students who panic at the last minute. And panic is appropriate if you wait till the last minute or beyond and find out that you have two finals at the same time. And as always, I'm kind of a snot about stuff like that. And so you need to be prepared. You need to look at the final exam times for your classes. And if you have a conflict, we will be addressing those. Remember, our final is a common time final exam. And the time of the final that's listed in the syllabus is correct. It's Tuesday, May 8th at 7 p.m. So you eat a hearty dinner and then come and take the final for those of you who will need to take it. The deadline to change your final exam time. And if you haven't done that, you need to go to your dean's office. You get a special form. You get signatures. It's a process. The deadline to get that all accomplished is April 13th. So we're still 3 weeks out from that. So we have plenty of time. But you need to start checking. Don't wait till the last minute. If I were you, I'd check right now. Pause the video. Go check and see the final exam times and see if you have a conflict. You may find you have one not with this class, but with some others. It'd be helpful to know in any event. So try that out. Check it out and let me know. Okay, the first thing I'm going to do is go through some slides. I'm going to share I'll share a portion of my desktop with you here, provided everything works correctly. I'd like to show this as a PowerPoint. It is a PowerPoint, but you won't see it as a PowerPoint. I think I posted the PowerPoint actually, and I've got it as a PDF here. And I'm doing that so I can share it properly. If otherwise, it takes over everything. So I'm going to share that with you here in just a second. We're going to talk about incremental analysis today. I'm going to go through some slides about incremental analysis. Then we'll go through the worksheet, the spreadsheet. We'll solve the problem, and hopefully that will solve that for you. So if you have questions about it, make sure you bring those up early next week. I can't say one way or the other at this point whether incremental analysis will be on the next quiz. It is going to show up somewhere. I'm fairly sure. So let's see if I can share my desktop, part of my desktop, and there we go. Okay. These are the file from chapter 6 that I was working on Monday. Let's sneak down here to the relevant part. Oh, sorry, I went right by it. Here we go. Incremental rate of return. You will remember on Monday, I talked about this just a little bit. And that is, we're going to look at increments of investment. And I would draw you a picture, but I don't have a really good way to draw a picture. So maybe I'll save that till Monday, and that will give you all something to look forward to over the weekend. I hope that what we do today will be sufficient without me drawing my bucket picture. Number one here, arrange alternatives based on increasing capital investment. So here we have three alternatives, A, B, and C, but notice that I've listed C before B because C requires less capital investment than B does. So we start with A, that's the cheapest, then C, more expensive, then B, even more expensive. Now we would remove any alternatives that have an internal rate of return less than the MEAR. We don't have any less than the MEAR. I don't really remember what the MEAR is for this problem. I should know what it is. Maybe we'll get it on the next slide. But I show here the internal rate of return, the IRR, for these individual alternatives, and they're all above the MEAR. Let me go back and see if, we're doing this same example problem that we did before. And so the MEAR is 10%. There's our problem statement. There's alternative A. Notice, so here's where we swapped C and B because of the first important step of ranking these in terms of initial capital investment. The MEAR is 10%. Useful life is 10 years. So they're all adequate. They're all good alternatives. So we keep them all. Step 3 here says calculate the incremental rate of return for the first base alternative and the second alternative. Now, what that means is that we will look at the incremental rate of return for the extra investment required in C over A. So let's notice there's A and B under that. We'll come back to that in just a minute. Let's look at what's going on. So here we have our cash flows for A. 18%. It means A is an acceptable alternative, and we start with A because A is the cheapest. It requires the least capital investment. So is the increment justified? I put a yes down here just to signify that it is justified over do nothing. A is better than do nothing. Now, here are our cash flows for C, our original capital investment, and the annual revenues less expenses. And I'm simply going to subtract the cash flows for A from the cash flows for C. So you'll notice alternative C requires an extra or additional investment of $700 over alternative A. And the payoff for those extra dollars is that C delivers $125 more revenue, less expense each year than A does. So the question is, would we invest if we had $700 extra to invest? If we had $700 extra, would we rather use it to move from A to C, where we would invest the $700 and get $125 extra? Or would we take that $700 and invest it at the MEAR? So we have $700. What would we rather do? Invest it at the MEAR of 10% or move from A to C and invest it to earn 12%? So we calculate this internal rate of return, and the internal rate of return is 12%. That means we're earning 12% rounded to an integer, 12% on our investment of the extra $700. So you can think of this increment of investment as like a separate investment, if you will. But since the IRR is greater than the MAR of 10%, that means that this is an attractive investment, which means that C is a more attractive investment than A. Okay, C is more attractive than A. Now, this doesn't mean that C earns 12%. Remember, we've already determined that C earns 17%, right? So the alternative C by itself earns 17%. But in comparison to A, the increment of investment between C and A earns 12% return. Okay, I hope that is somewhat explanatory. And so our answer is yes, the increment is justified because this rate of return is greater than the MAR. So investing the additional $700 in C instead of A will earn a return higher than the company's MAR. So C is better than A. Remember, again, we never would compare this 12% here to the 18% over here, for example. All comparisons of a rate of return are to the MAR and to the MAR only. So going back a slide, so this is the IRR for the increment is higher than the MAR. Bingo, that's this case. Second alternative becomes the new base alternative, and the first alternative is rejected. If the IRR had been less than the MAR, then C would not have been better than A, and we would keep A as the choice. So if this 12% here had been less than the MAR, less than 10%, then we know that that increment of investment required to go from A to C would not have been worth it. We would have been better off sticking with A. Okay, let's look then, since C was the winner, let's look at the next comparison, which is B versus C. And we form the next incremental investment, B minus C. B requires a $2,300 more investment over C. You get, in return for that $2,300, you get $300 more per year. We solve for the rate of return just for the increment, and we find that that's 5%. 5% is less than the MAR of 10%. So that incremental investment doesn't meet our hurdle rate of the MAR, doesn't meet our criterion. So no, the increment is not justified. B is not better than C. So we see here that C should be selected. C is the winner. C is the choice among these three. So a few things to say. First of all, let's go back again. Notice that C did not have the highest rate, internal rate of return, right? C was not the highest rate of return. So don't pick, again, this may be the last time I say it, do not select by comparing rates of return. It's a false comparison. And like I mentioned in class on Monday, it's a false comparison. When you're in a meeting and somebody starts comparing their internal rate of return to yours, it's a false comparison. So just be cautious of that. And the second thing, I think I'm finished here. This is just a summary slide. And that's all for that. So I'm going to stop sharing my screen. You get to see me again here. I liken this method, the incremental analysis method, to King of the Hill. I'm not sure if any of you played King of the Hill when you were young, maybe preteen, right? Because for teenagers, it's just too sophisticated. But when I was growing up, we lived in a neighborhood where there were some houses being built, and right across the street was they were building a house, and in Missouri they dig the foundation out to put a basement in. Every house had a basement, and so they're digging for the foundation, and they had this big pile of dirt, and of course it was probably not very tall, but to me at my age, I don't know, 6, 8, probably 10, it seemed like a mountain, and so of course there were a bunch of if there'd been girls playing, they would have been included, but there weren't. Just happened to be us guys, teenage boys, not teenage, young boys in the neighborhood, and we played King of the Hill. Of course, you've got to do that. So somebody runs up to the top of the hill. The first one up there is the King of the Hill, and then one by one, somebody comes up and tries to push you off, and if they push you off the hill, then they're the King of the Hill. And if you push them off, then you stay as King of the Hill. That is exactly what incremental analysis is. The least cost alternative is the King of the Hill. And then as the investment amounts go up, in turn, the alternatives climb up to the hill and try to become King of the Hill. Is that increment? Is the extra investment worth it? And if it is, they will knock off the defender, right? And the challenger is the new King of the Hill. And the other guy, the one that got knocked off, he's a loser. He's a loser. Got a big L on his forehead because he got knocked off. And once the loser falls off, the loser never comes back, right? So you eliminate them. They're gone. And so once you eliminate one of these alternatives, they never rear their head again. They're rejected, they're eliminated, not to ever come back. And so each alternative in turn comes to the hill, top of the hill, hoping to win. And the one left standing at the end, the King of the Hill at the very end, when all alternatives have been decided and compared, is the winner. That's the selection you make. Now, as it turns out, this is useful for the numbers it generates. It doesn't help you make the decision any easier necessarily. So it's always good to have these extra rates of return. These are great selling, marketing points, if you will, for projects. It doesn't help you make your decision, because I will tell you that if we had used the present worth criterion on this problem, the winner is C. So the winner with the present worth criterion is going to be the same winner that you get with incremental analysis, exactly the same winner. There you go. That's incremental analysis overview. Let's solve a problem with incremental analysis. Let me switch over here and get rid of that and get rid of this. Sorry, I've got a bunch of stuff open on my desktop, just like you guys do. And sorry, I should have been more prepared. Here we go. Let's look at the spreadsheet. So open up your spreadsheet and follow along as we work through this through this problem. And hopefully, I hope you'll see the value of this. This is problem 613, by the way, and I believe this is a homework problem. And it seems a little difficult as a homework problem, but it turns out, with of course using it on a spreadsheet, if you follow through and develop the cash flows properly, you're in good shape. So let's go here. And it's not exactly what I wanted to do. Let me stop sharing there. Let me try this one more time. Failing miserably yet again. Let's try one more thing here. Okay, let's keep it going. I don't know where I am here. Okay, I lost myself for a minute. I couldn't even see myself on it. Okay, let's try one more thing. Bingo, here we go. Finally. Okay, here's our problem. And you can see for my version here, we have the MAR of 10%. Here are the cash flows. And looks like ER1 for ER1, we have a geometric gradient going on here of 5%. So each year of the 6 years, the gradient is 5%. That is, the cash flows are 5% larger than the previous year. ER2 is an arithmetic gradient. Each year's cash flows are $125 greater than the previous year. And for ER3, it's like the cash flows each year are constant. There's our investment. Notice that in contrast to what we looked at on the slides, I've got negative. Gone ahead and put negative values in here for the investment amount to reflect negative cash flows. So here we are. This is something we've seen dozens of times. So this shouldn't be, if this is new to somebody, time to drop. I have calculated, didn't need to do this, by the way, I don't think. I have calculated the present worth of each one of these series of cash flows. And there it is. So I can tell you right now, right, the winner is ER1. That is the best of the three, is going to be ER1. But we will solve this using incremental analysis. Now, we know that ER3 is acceptable. Notice it's the least cost investment. So the order of our analysis here will be ER3, ER3, and then the next least investment is ER1, and finally ER2 will be the final alternative that we examine. The first thing we need to do is make sure that ER3 is acceptable, that it actually meets the requirements, right? That it satisfies being an acceptable alternative. So ER3 versus do nothing. Well, that's very simple. It is simply the cash flows for ER3, because do nothing would be zeros across the board. And we will find the internal rate of return. Whoa, sorry. I lost everything there. We will find the internal rate of return for these cash flows. And we know, by the way, right? Well, it's going to tell, oh, it's going to have to change the format. We know that this is going to be greater than the MAR. Change that to a %. Greater than the MAR, right? Because the present worth of ER3 is greater than 0, calculated at the MAR. So we know that the rate of return for ER3 is going to be greater than the MAR. So we knew that ER3 was fine. We knew it'd do nothing, but just the formality there. So ER3 is at the king of the hill, right? Up at the top of the hill, feeling pretty smug. And the next comparison then is ER2. So we will look at the cash flows. ER2 minus ER3. And to do that, again, the beauty of spreadsheets, we're just going to say ER2. Why did I say ER2? If I could erase the video, if I could edit the video, I would do that. But I'm not. ER1. My fault. My bad. You're yelling at me. That's okay. Because ER1 is the next investment level up. I said it was ER1. Not paying attention to my own problem. Equal ER1 minus ER3. It's just that simple. ER1 minus ER3. And that goes all the way down for each year. And there we go. There's the incremental investment is $16,000. The incremental positive cash flows each year, there they go. They go up by, it's a kind of a squirrely increment because you're doing gradient minus a constant. So it's going to be, as it is here, a geometric gradient. It'd be, well, never mind. There's the difference. You get that? And the IRR. So what's the rate of return? Now, again, we know, I just can't keep my screen sane here. We know, right? We know that ER1 is going to be the winner. So I can tell you right now that this incremental rate of return is going to be greater than the MAR. Wow, 33%. So remember, we're not comparing 32% to 12%. We are not doing that. We're comparing 32% to the MAR of 10%. That's the only comparison we make each and every time. Greater than the MAR, so ER1 has, that's a big rate of return. ER1 has thrown ER3 down. The ER3 is running home crying. ER3 is done. ER1 is the champion. ER1 is currently the king of the hill. And so now we have one alternative remaining, and that alternative remaining is ER2. So we'll look at ER2 minus the current winner, ER1. And again, very simple. ER2 minus ER1. ER2 requires an additional $28,000 of investment, and the extra cash flows we get each year, ER2 minus ER1, they all are positive anyway, except the final one. So there we have it. We can look at the internal rate of return of ER2 compared to ER1. We know already, don't we? You're with me, aren't you? We know that this is going to be less than the MAR because the winner has got to be ER1. Ah, look at that. This happened to me before. Look at that. What do you think? Does something jump out at you? Remember, change of sign, right? So we have in the cash flows one change of sign, two changes of sign. So we could have as many as two possible solutions. And when that happens, sometimes your rate of return goes belly up, right? You get that dreaded pound num, hashtag num, num num, tough. So we need to give it a guess. I think it's going to be less than 10%. So let's give it 5%, 0.05 as a guess. Okay? Well, that didn't work. How about a different guess? Let's give it 0. Gosh, that isn't helping. How about 0.11? Oh, geez. What am I going to do? What am I going to do? 0.09. I can't get it to work. I cannot get the right answer here to, or an answer to pop up, right? That's horrible. Let's keep trying. Am I ever going to hit it? What do you think? I want you to notice something. I want you to notice something. And some of you may have already caught this. Look at these cash flows. You know, sometimes you have to, we can't get stuck in just using our tools. We have to step back and use some logic. Let's do something. Let's add up these cash flows. Just add them up like no time value of money. Negative. This it's not red, but this is negative. If I change the format up here, it'd be negative number. So here's what that says. Each year, you know, each year we're getting these positive cash flows, but the sum of all positive cash flows, even happening in the future, and remember, future values brought back to the present are smaller at the present. All of these cash flows combined don't make up for the initial investment. So in fact, we're not getting any rate of return at all. We're a zero rate of return would happen if this sum were 0, right? That would be a 0 internal rate of return, but this is negative. So we're absolutely losing money. It's not just we're not making the mark, we are losing money. And if the sum of your cash flows is ever negative, the IRR or rate functions will never give you a rate of return. And you'll get this ugly, ugly result. So hopefully lesson learned, right? If you keep getting this pound num, and it would have happened even if this had been a positive number down here in that cell, stop and think, look at your cash flows, see if it makes sense. So here's our winner. ER2 is obviously a loser, big loser. So ER1 was the king of the hill at the time. ER1 is the champion, or the Cahampion. I hope that makes sense, that you understand how all that works. For each of these problems, we can work through them that way. That is, start with the smallest, compare it to do nothing first, make sure that it's acceptable. If it's not acceptable, if ER3 had not been acceptable, we would have just gone to ER1. ER1, we would not have compared to ER3 because ER3 is not acceptable. We would have compared ER1 to do nothing. You do that until you get the first king of the hill, right? And then in order, you continue to compare the next alternative, again, ranked in order of increasing investment. You can continue to compare them in the King of the Hill way that we did until you get, I've gone through all of them and you get a winner. So I'm going to switch back to myself here. Sorry. And there you go. That's incremental analysis. I think we're done. I don't even know how long I don't know how long these are until I stop. I hope it wasn't too long. I might have rambled on for hours. I could ramble on for hours. I'd like to, but I've got to go shovel my driveway. So I need to go home and shovel my driveway so I don't get yelled at later. There are incremental questions in the homework, so you can examine those. Those will help in additional understanding. You can watch this video over and over and over again. Have your friends over, you know, with AirPlay or Google. What's that called? Google casting. You know, you can show it on your big TV, and all your friends can come over. Anyway, I'm done rambling on. I hope you have a good day. Stay safe. Be careful when you're walking. It's tough to hit an icy spot. Could happen. Could happen in the morning also, so be careful in the morning. And I will see you in class. If we don't get another one of these, I'll see you in class on Monday. Have a nice weekend.